Let's learn about decomposition reactions. Using a dancers on the dance floor analogy, in a decomposition reaction, you're starting out with two dance partners that are currently dancing together. And over the course of the reaction, these two particles split up. So by the end of the reaction, you have this particle and this particle. They've gone off in their separate ways. Quite often in decomposition reactions, we see a change in state of matter. For instance, you might start with maybe a solid and you heat it up and you knock those particles apart and you produce some gases. Let's head into the lab and perform a decomposition reaction. I'm going to demonstrate for you a decomposition reaction. In this reaction, I'm going to start with some tin chloride. Tin chloride is an ionic compound. It's a salt. And when dissolved in water, salts take on a state of matter called an aqueous state of matter. So I have my aqueous solution of tin chloride, and in this particular reaction, I'm going to dump energy into it. I'm going to supply that energy with a 9-volt battery, which I have secured using red and black electrodes to this petri dish. I've attached pieces of paper clips to the electrodes to increase the surface area, so here comes our tin chloride. So I've added my tin chloride to the solution and I'm supplying energy in the form of that 9-volt battery. And right away you can see something is already happening here. Now, keeping in mind that this is a decomposition reaction, what do you think is happening to the tin chloride in this reaction? What do you think these products are? So this is a pretty dramatic reaction. Out of that tin chloride solution, we have the appearance of this silvery solid. This is pretty astounding. What do you think that silvery solid is? Well, it turns out that what that solid is tin metal. Now remember, we started with tin chloride. And when I applied energy to that aqueous solution, the tin separated out from the chloride. So the tin atoms went and found other tin atoms to form this beautiful silver branching sort of snowflake-like structure inside the petri dish. And then the chlorides went and found other chlorides bonded together and made chlorine gas. So the chlorine gas escaped into the atmosphere, but the tin metal was left behind in the petri dish. This is a little bit of an unusual decomposition reaction in that one of your products is a solid metal. So, pretty striking example of a beautiful decomposition reaction. Now, in the decomposition reaction that we just saw in the lab, we started out with tin chloride, that's SnCl2. And when I hit it with some electricity, we saw this beautiful metal appear. Now, if you understand how a decomposition reaction works, you might have guessed that that metal was tin. So using our dancers on the dance floor analogy, we had tin and we had chloride, which were bonded together. When we hit the tin chloride with some electricity, the chloride went off and formed a gas. And the tin was left as a metal in that petri dish. It's actually one of my favorite decomposition reactions. If we were to illustrate this reaction, it might look a little bit like this. Here's the tin chloride, and when we hit it with some electricity, it knocks the chloride off of that tin atom. The chloride atoms bond together and escape the solution as chlorine gas, Cl2. What's left is a tin atom. If you're trying to identify a decomposition reaction, the important thing is to recognize that these dancers started off together and then by the end of the night, they're dancing solo. So pretty interesting and kind of unusual example of a decomposition reaction.